Hello and welcome to this video. In the previous video, we treated domain of a function, relations of a function, and what a function is itself. In this video, we'll be treating the range of a function and how to find it. And we'll be solving a few questions on the range of a function. So, we realized from the previous video, if you've not watched, you can go back and watch it. If you've watched it, you can continue. If you already understand the domain of a function, then yes, you can continue. So, from the previous video, the domain was the set of x values for which the function f of x exists. The range is the set of function values f of x that can be outputted. In other words, the set of values of y that a function can bring out is the range, the set of members in the codomain. Remember from the previous video that a function is like a box that transforms a certain value into another value. So the set of these values form the domain, and the set of these values form the codomain or the range. More preferably, we use the range in our dealings more than the codomain, but the set of codomain is the range. Let's try a question and see how we can find the range of a function. For example, f of x equals 3x plus 2. To find the range of values, we have to transform the function in another way. Now stay with me. We write the f of x as y, since we know the f of x is the same as the y values. Then the function now becomes y equals 3x plus 2. Then we make x the subject of the equation. So we get y minus 2 equals 3x, divide both sides by 3. Then we get x equals y minus 2 all over 3. Then from here, we apply the same rules we applied when solving for the domain. So the rules were that we should avoid getting a over 0 or square root of a negative number. These were the rules we were dealing with when finding the domain. So in range, what we do is that we express the function in terms of y, and then we apply the same rules, and the values we get will give us the exemption or the exclusion for the range. So over here we can see that there's no way we are going to get a number that gives us an imaginary number, since the domain is 3 and cannot be 0 under any circumstance. It doesn't have any x value there, and there's no radical sign anywhere. So the range will be, range is y such that y is a member of all real numbers, no exception. Let's take another question. F of x is equal to 3x minus 2 all over 7. Again, we change f of x to y. We get y equals 3x minus 2 all over 7. We make x the subject, so 7y equals 3x minus 2. 3x equals 7y plus 2. Divide both sides by 3. Then we get x equals 7y plus 2 all over 3. From here, we can tell that the range, again, is y such that y is a member of all real numbers, since there is no radical sign and the denominator cannot be equal to 0. Let's take another question. F of x equals x plus 1 over x minus 2. Again, we make f of x y, then we get x plus 1 all over x minus 2. Then we get then we get y multiplying x minus 2 equals x plus 1. This gives us xy minus 2y equals x plus 1. Then we group like terms, bring all the x's to one side, so y minus x is equal to 1 plus 2y. Factor the x out, y minus 1 equals 1 plus 2y. Divide both sides by y minus 1. We get our x being equal to 1 plus 2y all over y minus 1. From here, we can now find the range, since by using the rules above. Let's go back to the rules. So we should avoid getting a number over 0 or square root of a negative number. You can clearly see here that there is an instance in which the denominator here will be 0, and we have to find that instance. So it will be 0 if all of this is 0. So y minus 1 being 0, y is going to be 1, meaning that the range is a set of y such that y is a member of all real numbers, but y is not equal to 1. Y is not equal to 1. Let's take yet another question again to solidify our understanding of the subject. Here of x equals 2x minus 1 all over 3x plus 5. We express it as y, so y equals 2x minus 1 all over 3x plus 5. Y multiplying 3x plus 5 equals 2x minus 1. 3xy plus 5y is going to be 2x minus y. Group like them when we factor them out. 3xy minus 2x is equal to negative 1 minus 5y. Factor the x out. 3y minus 2 equals minus 1 minus 5y. Divide both sides by 3y minus 2. Get x to be negative factored out. 1 plus 5y divided by negative factored out negative 3y plus 2. The negative will take care of each other. We're going to have x to be 5y plus 1 divided by 2 minus 3y. So, let's again we equate the denominator to 0, so 2 minus 3y equals 0. We get y to be 2 over 3. So the range is a set of y such that y is a member of all real numbers, but y is not equal to 2/3. F of x equals 5x minus 5 over negative x plus 6. F of x as y multiplied to this negative x plus 6 equals 5x minus 5. This is negative xy plus 6y equals 5x minus 5. Now grouping like terms, 5x minus xy is equal to minus 5 minus 6y. Factoring x out, we have 5 minus y equals, factoring negative 1 out, 5 plus 6y. Divide both sides by 5 minus y. 5 minus y gets x to be equal to negative 5 plus 6y. Factor out negative 1 here, we get negative y minus 5. This takes care of each other. Then gets x to be 5 plus 6y over y minus 5. Taking the denominator, y minus 5 equals 0, y will be 5, meaning that the range should be a set of y such that y is a member of all real numbers, but y is not equal to 5. Y is not equal to 5. Try the following questions on your own and see how best you are able to solve them. So this is the solution for the problem above. See you in the next video.